We're going to continue in Chapter 2, and we're going to talk about outliers, these extreme values or observations in the data. What happens is you see the bulk of our data, it will end up being, in a distribution somewhere along the number line, and you'll have these numbers that are way off. So, for example, if a lot of my numbers in my distribution are 20, 21, and 22, and let's say we have 100 data points and they all fall in numbers between 20 and 22, and all of a sudden we have a couple of data points that are 99 and 100, they would be considered outliers. They're unusual. They're unusual values. And we talked about what could cause outliers. It could be chance occurrences, measurement errors, data entry errors, and sampling errors. So why we have an outlier is very important. So how do we find an outlier? Well, just looking at a distribution, you can't just say something's an outlier. We have an empirical way to find this out, or a way that we can calculate it. We have things called a lower and an upper fence, and if our data is smaller than the lower fence, that will indicate that we have an outlier. And if our data value is greater than the upper fence we calculate, that tells us that we potentially have an outlier, or that we have an outlier. Now this is the command we use to get a box plot. And what's nice about Minitab is Minitab will let us know that we have an outlier. If we see asterisks on the left or right-hand side of our box plot, that's telling us we have outliers. And our whiskers, or the lines, will not go out to our maximum and minimum data value. If we should have outliers to the right, then the whisker or the line will go to the upper fence. If we have outliers to the left, or in the lower part of our data, then our left line will only go to the lower fence. And if we have outliers on both sides, then the lines will go out to both the lower and the upper fence. So here's some data that we see where on the left-hand side, 100 is our minimum. On the right-hand side, the right line goes to the upper fence, and we see that we have a outlier way out there past 300. Your book will not have the outliers. The line will go all the way out to the maximum value. Remember, the outlier is in the data, and this particular one where it has one asterisk, that is our maximum value. The whisker in the book, or the line in the book, will go all the way out. And we won't know just by the box plot that we have an outlier. We would have to do our calculation and see that indeed we did have an outlier. So I opened up Minitab and I have some data. Once I've done this, what I'm going to do first, so in the describe command, I see that I have N is 14, that's how many are in my sample space. And look down here, I have 14 data points. It gives me them. Remember, our book does Q1, the first quartile, and Q3, the third quartile, a little differently. So we have to actually calculate that for our homework and our work. So I'm going to show you right now how to do that. So let's say that I had this data set and it wasn't sorted. How do I sort it? Well, I do the sort command, and then I say sort that data. My data happens to be in C1, and put it in another column. So I'm going to say put it into C10. When I hit enter, there is the sorted data. Now, as you can see, my data originally was already sorted, so nothing really changed. So now how can I use Minitab to help me find the first and third quartile, since I can't use Minitab's calculation of it? Well, I know that I have 14 data points, so I use my how we locate the median. So we know if we have 14, 14 plus 1 is 15, divide that by 2, that says 7.5, which means I'm supposed to add 16 and 19 together and divide by 2. That's where the 17.5 comes in. But we already knew that, and I told you that the median would be okay. So what do we do next? Well, since we know that 7 and 8, we calculated those two to find the median, which was 17.5, that means that 16 is included in the upper half of my data. So I have 7 data points in my my lower data. So I need to find from 7 data points the median of that, and that will give me Q1. So 7 plus 1 is 8. Divide that by 2 is 4. So my Q1, my first quartile, is 7. Now, how do I do my lower half? The same way. I've got 7 data points here, so of course it's going to be the fourth one. 1, 2, 3, 4. So it's going to be 27. So I've got my 5-number summary now for this data. And the 5-number summary, and I'll write it in here so that you guys can see it. So here I write it in Minitab. When you see a $sign, that's a comment in Minitab, so Minitab won't recognize that line at all. So I could write that comment. So here's the 5-number summary by the way our book does it. So I could also do a dot plot of this data, and it would look, now remember it's going to be the dot plot using the quartiles in Minitab. So let's see if we have any outliers according to Minitab's method, which is going to be very similar to the book. Box plot C1. Now, I'm not just going to hit enter. If I hit enter, I'm going to get a box plot that's vertical, and I don't want that. I want a horizontal box plot, so I use the subcommand transpose. And that gives me a nice box plot of my data, and I don't see any stars, so I don't have any outliers. But let's say that this was the box plot in your book, you wouldn't know. So how would I calculate and know whether or not I have outliers or not? Well, that's what we're going to do next. So I'm going to calculate the lower fence in Minitab. I'm going to let this constant, it's called K1, or I could call it K2, K, any number, is a constant in Minitab. But I'm going to let K1, it's going to be our lower fence for the data in C1. And this is what the command would look like for that. So I put in here, remember that the lower fence is our first quartile minus the magical number, but it's not magical, there's a reason for it, 1.5 times the interquartile range. But remember what the interquartile range is, it's Q3 minus Q1, and in our case, Q3 is 27 and Q1 is 7, so our interquartile range is 20. Now we're ready to calculate that, the lower fence. So there's our command. Let K1, let this constant equal, and we do the equation, 7.0, which is Q1, minus 1.5 times the interquartile range, which was 20. And then we say print K1. So then once I have that right here, I'm going to hit enter, and there's our lower fence. Is any of our data here smaller than negative 23.00? No, it's not. So 1 is the smallest data value, and that's much greater than negative 23. So we have no outliers in our data on the lower half of our data. Now we have to check to see, look at our upper fence and see if we have any outliers on the right-hand side of our data. And so we do the same procedure we did for the lower fence. So here we have, calculating our upper fence in Minitab, Q2 is the upper fence for the data in C1. I chose the constant to be called K2. Remember, the upper fence is the third quartile plus 1.5 times the interquartile range. So in our case, our interquartile range is going to be Q3 minus Q1, which we already knew was 20. So here's our Minitab commands. Let K1 equal 27. Whoops, that should be plus. The interquartile range is Q3 minus Q1, but our upper fence is our third quartile plus 1.5 times the interquartile range. So we're going to, and then once Minitab does the arithmetic operation, it's in the buffer of its memory, we have to call it out and say, hey, print it, we need to see it, and that's why we say print K1, but it's not K1, it should be what? K2, because I had copied and pasted, so I forgot to change a couple of things. Sorry about that, guys. So when I hit enter, I see that my upper fence is 57. So I go back down to my data. Is there any data greater than 57? No, my greatest data point is 54. So I have no outliers at all in my data set.